Hello everybody, welcome back to my channel. So continuing with the problem solving tools playlist, we were looking at stack data structure. So today we will be solving another real life problem based on stack. So today's problem is implementing the undo and redo feature we used to seeing in text editors like Microsoft Word. So we will implement the undo and redo functionality. So what is undo and redo? So let's first look into it. So for understanding the problem, we all must have used Microsoft Word and Google Docs. There we have seen a feature called undo and redo. So what undo and redo does is, suppose we are typing some words and we have done some mistakes. So we have to undo the recent operation. So suppose if we have inserted a character and we have undone that insert, then it will do what? It will delete that specific character. So undo means basically the opposite action of a specific action. And what does the redo means? The redo means that if something is undone, we have to undo the undone thing. Like if we have inserted an element and we have deleted it, it would be undo, and if we redo it, it will be again inserted. For example, if suppose I have inserted a, then b. Now at this stage I feel like this is a mistake and we have to undo it, so it will be deleted. So this is undo. And suppose now after some time I have realized no, that was correct, so I have to bring back b again. So what we will do is we will do redo. So that will do what? It will bring back b once again. So this is the basics of undo and redo features. So how can we implement it using a stack data structure? We will see in this video. Okay, so I have written down some set of instructions like insert, delete, insert, and so on. So let's go through this set of instruction and let's see how this undo and redo thing actually works. So first insert a. So let's see, we have a empty string where we first insert a, then it's insert b, then it's delete b. So delete basically means, for this sort of example, we are taking that the delete keyword will delete the last element from the string. So delete will delete b, then insert c. Okay, so we will insert c, then insert d, so we will insert d. Now the undo comes. So what does the undo means? Undo will do the opposite operation of the previous operation. So it is insert d, so the undo will do what? It will delete d. So it will delete d. Now it comes redo. So what redo will do is exact opposite of what undo did in the previous line. So undo deleted d, so it will once again bring up d. So at the end of all this instruction, our answer would be a, c and d. So this is what we have to do, and let's see how we can do it. So for this we will use two stacks. So two stacks will look like this. One stack is for undo operation, let's write it over here, and one stack is for redo operation. Okay, so far so good. So what we will do in the undo stack is, suppose we have some set of instruction, we will store the opposite instruction of the specific instruction in this undo stack. And why is that? Because let's just think for a moment, if suppose we have an insert operation and after this operation we have to undo it, so how can we know that what is the reverse operation of this operation? So that will be fetched from this undo stack. So that's why we have to do what? If suppose we get an insert operation, then the exact opposite operation would be delete. So in short, I am writing it as del. So we will be storing del in the undo stack. Again, we will be storing del because it is also an insert operation over here. Then it comes a delete operation. So if there is a delete operation, then it will store insert, inst. I am writing it in short. So whenever any operation comes, it will store the exact opposite of it. So let's suppose these lines are not present over here. After this delete, we are doing an undo. So what it will do is, if suppose these three lines are executed first, so it will give first insert A, then insert B, then delete B. So we are undoing this delete B. So that means what? We will look in the top of the stack of top of the undo stack. We will see that okay, we have to insert. So that means we have to insert the previously deleted item. So we will delete this instruction from the stack or other pop and execute this instruction over here. So again we will insert B. So that's how this undo feature is working. So now let's see how we can implement this redo feature. So let's think for a moment. Whenever we are pushing something in undo stack, we are just doing the opposite of any normal instruction, and this redo functionality is exactly undo of undo. If you know what I mean, like if you have any doubt, just go back and watch the video once again. This redo is basically doing undo operation of undo. So that means whenever we encounter any undo instruction, we have to just oppose the undo instruction and store it in the redo stack. I hope this is making sense, because whenever we are undoing something, if suppose the user says redo, that means what? We have to do the exact opposite of that undo operation. So that's why we have to keep track of that undo's opposite also. So that's why we will store the exact opposite of what undo is doing. So here, before popping, it was doing what? Inst, that means insertion. So we will store, whenever we encounter any undo in the redo stack, its opposite, so it will be delete. So now here it was insert, here it was delete, here it was undo. So again if we do redo, that means what? It will undo the undo, so it will delete the B once again. So how can it know that it has to delete B? It will look at the redo stack, and at the top of the stack it has delete, so it will delete B once again. So this is how these two stacks are working in coordinates. Like whenever we get some instruction, we will store its opposite instruction in the undo stack, and whenever we get specific undo instruction, then only we will store its opposite to the delete. And why is stack is our preferred data structure over here? Because one thing is, for this feature of stack, LIFO, last in first out, so we have to keep track of the records, that what operation is coming after what. Like if there are two undo operations over here, like if there were another insert over here, there will be two delete. So we don't want that for this undo this delete will, I mean, trigger. We want for this undo this delete triggering. So that's why it is structured in such a way that it is keeping an order. For this instruction of undo, only the top of the redo stack, and this instruction will be executed. After that they both will be popped, then for this undo this redo will be executed. So that is how these two stacks are working. So this is exactly how we can implement this undo and redo feature using a stack, and this is a very uh, real life example I have given. This has use cases in many places, not only in Word or Google Docs. You will see like in Photoshop or any video editing softwares, they are having this undo and redo feature. So using these stacks you can do a very complex undo redo features also, but the underlying data structure is stack always. So I hope you got the implementation, or rather the intuition of this problem. Now let's go to the code editor and let me walk you through the code. So now we are at the code editor over here. So I will be quickly walking you through the code over here, and the link of this exact code you can find it in the description below, so you can go through the code and implement by yourself. So how this code is actually working is, we have two arrays called actions and letters. These actions are defining that actions it need to be performed, and these letters are in the showing that what element needs to be inserted, like for insert operation. If it's a delete or undo or redo, there must not be any element or letter passed, so that In that case there is empty string. So we are calling this function called func and passing these actions and letters. So let's see how this function is actually working. So we are initializing two stacks called undo and redo. So I have also shown in the basic stacks implementation video that how stacks in Pythons work. You can do it in your own preferred language as well. And we are also initializing one answer empty list, because in Python there is a thing that the strings are immutable. So that's why to change and manipulate things we need to use this list data structure, and after that we have to join the list. So that's a Python specific thing. You can use a string builder for Java or just string in C++. So that's a different thing. Okay, so first of all we are looping through the actions array. So whenever we are encountering insert, just see that we are appending the letter which is needed to be inserted. Like for insert a is inserted in our answer. Then, as I've explained in the whiteboard, we are appending the reverse operation and the letter that is inserted in the undo stack. Over here we can see. And if it is delete, then it's pretty simple. If the length of the array is 0, then it's an edge case that the first operation cannot be delete, obviously. And if the length is not 0, then answer.pop, because we are only deleting the last element. And then we are also again storing the reverse operation like insert and the last element, because we have just deleted the last element. So these two steps are pretty straightforward. Now comes the interesting part. If it's an undo, first of all, the first operation cannot be undo because there is nothing to be undone. So that's why it is pretty self-explanatory. So that's why I've written down over here. Else, if we are actually taking two variables, act and let, because notice over here in the undo stack we are storing a list of two items. One is instruction and one is the element. So we are just extracting the top of the stack and extracting its action and storing it in act, and its letter and storing it in let. So let's think for a moment. If we have pressed the undo button and the action is delete, then means what? We have to do its reverse operation. Sorry, in undo it is already delete. That means its reverse operation was done previously. Like if insert was done, then in undo stack there is delete. So that's why we have to delete. So that's why we are doing answer.pop, and just because the undo operation is done, that's why we are also popping the undo action or undo action from the undo stack. So after that we are also appending or inserting its reverse, like undo's reverse, in the redo stack. You are understanding this part, right? I have already explained in the whiteboard. So that is exactly what this line of code is doing. And else, exactly the same thing. If it's not delete, it's obviously insert. So that's why it's inserting that letter. And again undo stack is popped and its reverse is storing in the redo stack. After that only we are left with one instruction, that is redo. So if redo stack is empty, then first operation cannot be redo. Okay, or rather if we have not undone anything, we cannot call redo. So that's what I have written over here. So after that it is exactly same as the undo part, except it is just manipulating with two stacks. So that's why wherever there were redo stack, it is exactly opposite over here. Like here it was redo, so here it will be undo, and we are using the same logic. You can see over here. So this is also pretty self-explanatory. I think if you walk through the code by yourself, then you will understand. So this is pretty much it for the function, and after that we are just joining it and we are returning the answer. So let's run it and see how this code is working. So it is giving us answer A, B, C, E. So let's see how it is A, B, C, E. So first it is inserting A, okay, then inserting B, okay, then inserting C and D. Then it is undoing the insert. So that means D is deleted, then again it's inserting E. So that means the final answer is A, B, C, E. So that is pretty much it for this video, and I hope you have enjoyed and learned something new. So if you liked it, please do consider subscribing for more content, and thank you for watching.